In this tutorial, we learn how to use our TI NSpire CX to find a curve's points of inflection. I'm on my TI NSpire here, and as you can see, I've already plotted a curve. If you want to plot the same graph, this curve's equation is shown right here. Now remember, a point of inflection is a point along a curve's length at which the second derivative equals to 0, and on either side of that point, the second derivative changes sign. In turn, that tells us that there's a change of curvature. Looking at the curve we have here, we can see that there's a change of curvature somewhere in this region that I'm pointing towards right now. So let's see how to find that. The trick is to plot the second derivative of this function. And here's how we do it. We click on Menu. We then select the third option, Graph Entry Edit. And I'm going to enter another function. So I click on the first option, Function. Now, to make our TI NSpire plot the second derivative, we need to click on this button right here. That's the button just to the right of number 9 on our keyboard. And I click on it. Now I can see that I've got all of these options. And on the far right-hand side here, on the second row, we can see we have the second derivative. So I click on that. Now, since I'm differentiating with respect to x, I need to type x here on the denominator. And in the parentheses that we have here, I need to specify which function I wish to differentiate. And there's no doubt here I've only plotted one function on the calculator, so it should be f1 of x. To find that function, I go ahead and click on var on the calculator, and I can see here that the calculator has found f1, and that's the first function we typed. So I click on f1. Once more, I tell the calculator that the variable is x, so I type x. I exit the parentheses and I click Enter. And we now have this red line, and this red line is this function's second derivative. And this shouldn't be a surprise. Our initial function was a cubic, so if we differentiate it twice, we end up with a linear. Now remember, at a point of inflection, the second derivative equals to 0, and on either side of that point, the second derivative changes sign. So what we have to find now is the value of x at which this red line equals to 0. In other words, where this red line crosses the x-axis. For that, I go ahead and click on Menu. I select the sixth option, Analyze Graph, and I select the first option, 0. So I click on that. It's now asking me which graph to study, so I select the red line, and I click on it. And now it's asking me for the lower bound. For that, I place myself to the left-hand side of the point at which the line cuts the x-axis, and I click. And it now asks me for an upper bound, so I move to the right, and I can see there that it's found the 0. So I click. And there we have it. We can see here that the second derivative equals to 0 when x equals to 1.67. Furthermore, we can see quite clearly that on the left-hand side here, the line is beneath the x-axis, meaning it's negative, and on the right-hand side of 1.67, it's above it, meaning it's positive. This tells us that the second derivative goes from negative to 0 to positive, which confirms that we have a point of inflection when x equals to 1.67 with a change of curvature. And there we have it. We now know how to find points of inflection along a curve's length with our TI NSpire CX. And that's it for this tutorial.